right. Thank you all for being here. And today we will talk about events in the context of the largest logistics company in the Benelux. We will talk about scale and reliability and self-service in a fully serverless environment. As an added bonus, I will sprinkle in some CDK as well. This is a level 300 talk, so I will assume that you already have some knowledge about the services we're discussing, and I might introduce some new concepts and features that you might not know yet. Quick introduction. My name is Luc van Donkersgoed. I'm the lead engineer at the PostNL integration team. As I was just introduced, I'm 12 times AWS certified and was recently named an AWS hero. My current responsibility is to design and build a fully autonomous self-service event broker in AWS. And today I will take you on that journey. But before we start talking about the technological details, let me give you a bit of context about PostNL. By the end of 2020, we had about 4,300 retail locations. We employ more than 40,000 people. And in 2020, we still send about 8.1 million mail items, so that's letters and envelopes, per day. We also saw that in 2020, there was almost a 10% reduction compared to the year before. On the other hand, we're also sending 1.1 million parcels per day. And in 2020, we saw almost 10% increase in that volume. And today we will really be talking about the parcels part. So to get those millions of parcels from where they are to where they need to be, many teams and applications are working in concert. My team, the PostNL integration team, is responsible for making sure that the data streams between those applications are reliable and performant. Now, the logistics world is an event-driven world, so it makes sense to use an event-driven architecture there as well. So let's take a quick example at what an event is. So on the slide here, you see somebody delivering a parcel at one of our retail locations. The moment they deliver this parcel and it gets scanned into our systems, that generates an event. That event gets sent onto the event broker, which routes it to the delivery planner application. And the delivery planner application creates a plan on how that parcel should move through our systems. And that generates new events. And those events get routed to the collection application, to the sorting application, and to the deliver application. When a parcel arrives in our sorting center, it's put onto the sorting line. And on the sorting line, it gets scanned and gets registered. And those moments in time we call observations. And those observations get sent as events to the event broker as well. Those events get sent to the sorting controller, and the sorting controller plans where the parcel should go. On the next junction, should it go left, should it go right? And that generates events again. And those get sent to the event broker, which routes it to the sorting lines, but also to the delivery planning applications and some other services as well. Now, we just looked at one event, or maybe two events, for one single parcel, but we're sending millions of parcels. And all those parcels generate way more events than what we just saw. So in June 2021, we measured about 3.5 billion events being processed by our event broker. December is classically our busiest month of the year. And in December 2020, we saw about 5.7 billion events being processed by our event broker. Now, not every day is equally busy. So on the busiest day, we peaked at about 280 million events per day, and we peaked at about 10,000 events per second. Now, the logistics world is also a highly competitive world. So to stay ahead of the competition, we're constantly building new features and new services that our customers require. And it's very important to get those features onto the market with a quick time to market. So what we're currently seeing is that about 1 in 3 features that we're building at PostNL requires some form of integration and therefore requires some interaction with our event broker. Now, we do not know which innovations and which features and which services we will be building in the next year, but we do know that they will grow and that we will continue to create more events and that they will be sent to the event broker. So we're getting more producers, we're getting more subscribers, and currently we're estimating that by December 2022, we might be processing 14 billion events per month. And we might peak out at about 20,000 events per second. So that's what we're designing our systems for. Now, we believe that the primary way, the best way for us as the integration team to support our producing and consuming applications is to get out of their way. My team, the integration team, should be there to help and to guide these application builders and these developers to build their integrations. But we should not be there. They should not depend on our time and our availability to build those integrations. Instead, they should be able to produce and consume as they see fit, and my team should provide the tooling to allow them to do so. Yet we also work in an environment where availability and reliability are extremely important. Because if we fail to deliver events, then sorting centers will not work, trucks cannot drive, and of course, our consumers will be very unhappy. So it's always a balancing act between security, reliability, efficiency, and the flexibility for our producers and consumers. Now, before we go into the actual deep dive of the technology used, let me first introduce a few concepts that I have been using and will be using a lot. The first is producer. And what you see is that many of these terms in the event-driven world have overlap with terms used in the logistics world. But from now on, we will really be focusing on the meaning of these terms in a technology context. So a producer is any application that sends events to our event broker. A consumer is any application that receives events from the event broker. But of course, an application can both be a consumer, process those events, then send back events to the event broker and be a producer as well. An event itself is an immutable, self-describing set of data. And by immutable, we mean it's a snapshot of an event in past time. It might be a millisecond ago, but it's a snapshot. It cannot change anymore. It describes a moment in history. And by self-describing, we mean that the event does not provide, has all the additional context that you need to understand the event in the event itself. Of course, a receiving application can enrich that data, but the data itself, the event itself, should be self-describing. And the last term I want to introduce is a schema. And a schema defines the structure of an event. So a simple event might have a producer ID, a postal code, a destination house number, and the weight of the parcel. And the schema defines these are the 4 fields that are there. And this is the data that is stored in it. It might be a string, it might be an integer, it might have a certain range, and you can define it in a number of other ways as well. So what are we trying to achieve with the event broker? Well, we're really bringing it down to 3 main terms. It's reliability. We want to be able to guarantee event delivery and structure. It's flexibility. We want to be able to dynamically add producers and consumers. And of course, PostNL is a data-driven organization. So we want to have insight in the events that are being produced and consumed as well, so that we can actually act on these data streams. And all of this should, of course, be built in a serverless environment. Now, the simplest solution to achieve this would be to allow producers to publish directly onto EventBridge. And we chose EventBridge as our event transport layer because it is serverless. It scales almost to any scale. I think the default maximum is 100,000 events per second, so we easily fit in there. And it has some really nice features such as replay functionality and filter functionality for consumers. Now, of course, the availability of EventBridge is fine because it's completely managed and scales through AWS service. But the reliability of events on this solution would not be enough, because producers would be able to change their events and change their event structures. And if the consumers are depending on a certain structure, they might break, they might crash. So we need some work to do there. This solution is, of course, flexible because we can produce anything on it that we like and we can consume anything that we like. And Insight actually needs a lot of work because EventBridge by itself does not generate many metrics. And as I just said, we're a data-driven company, so we want those metrics. So we need another solution there. Now, the first thing we do is we add an API gateway in between the producers and EventBridge. API gateway has support for request validation out of the box, and it uses JSON schema draft 4 to achieve that. Then we specify a path, a URL per event, and we apply a JSON schema on that path. So with this in place, events published onto API gateway and then EventBridge are guaranteed to match the schema defined by the producer. And as we get more events, we just add additional paths, and all of those get their own JSON schema. We also store these schemas in EventBridge schema registry, and that will allow our consumers to see which events and their structures are available on EventBridge. And we'll get into this discovery and consumption part a bit later. So with the solution in place, we have better reliability because now we know that the events being published match the schema defined. We have the same flexibility because we can still publish any event that we like onto EventBridge. And we have slightly better insight because now we know exactly which events are available on EventBridge. So let's talk about the consumers for a little bit. The consumers can first read from the EventBridge schema registry which events are available. And because we apply schema validation at the gate, they can rely on the fact that those events match their structure. Then when they see certain events that they want to consume, they can add a EventBridge rule onto EventBridge and route that event to the targets that where they want to receive it. Now, currently, we support 3 target types. So we have an HTTPS endpoint in the consumer's account, or we have an EventBridge, event bus, deployed in the consumer's account, and we can route events there. Or we support that they provide an SQS queue in their consumer account, and we can route the events there. Now, all of this matches the basic EventBridge functionality pretty well. So let's turn up the complexity dial a bit. First thing is that the API gateway, as we described it until now, is available at a public endpoint. So that means that anybody that knows the URL, knows the path, would be able to publish events onto it. Now, we protect those endpoints using client certificates, and we created a client certificate vending machine that generates client certificates and matches them to a specific path using a custom Lambda authorizer. Now, any producer using a certain client certificate can only produce the event on that specific path that the client certificate clears. The reason we use client certificates here and not IAM is because we have a number of producers that are not on AWS. So we would have to provide some sort of token service, or we would have to give them long-lived credentials, which is not what we want to do. And also, PostNL has historically standardized around client certificates, so there's a lot of support for it in our consumer and producer applications. In a bit longer term, we would like to move more towards IAM, but we need to work with the teams around us to achieve that as well. Now, with the solution in place, we have further improved reliability because now producers can only produce what they are authorized for. Another artifact from our existing PostNL environment is that not all events are as small as they should be. So EventBridge has a hard limit at events, an event size of 265 kilobytes. And most of our events are very small, like 95% of our events are like 4 kilobytes. But some events might be larger. They might be 400 kilobytes or even more. Now, EventBridge does not support these large events, but we still need to support them in our environment. So to solve this issue, we added an ingestion function in between API Gateway and EventBridge. And the ingestion function measures the size of the event. And if it's smaller than 200 kilobytes, because we take some margin, it just forwards the event straight onto EventBridge. If it's larger than 200 kilobytes, it offloads the body of the event into an S3 bucket. And then it generates a signed S3 URL and forwards the signed URL to EventBridge for the consumer to receive. Now, I said before that event structure reliability was very important to us, but I'm also telling you now that we're actually mutating this event structure, so it actually isn't reliable anymore. Now, to tell you why that still works, we need to look at the event envelope. So let's say the producer produces this event. It has 3 fields: a postal code, a house number, and the parcel weight. And this is what they want to send to our event broker. We ask our producers and we enforce that they put this event in an event envelope, the PostNL envelope. The PostNL envelope contains metadata and 2 mandatory fields: the PostNL correlation ID and the original event date time at which the event was generated. Then the original event gets put into the data key. There are also some optional fields, which are event attributes, and the event attributes will later allow us to filter on this event. We will see why that is important on the next slide. But the event attributes is a simple dictionary of key value pairs. Now, when an event is small, so it's smaller than 200 kilobytes, it looks like the one on the left. It has the metadata, it has the mandatory PostNL correlation ID and date timestamp and the optional event attributes. And we add one additional key, which is the event truncation key. And in that, we put a Boolean called event truncated, and we set that to false. So this event was not truncated, but was forwarded as is onto EventBridge. Now, if the event is larger than 200 kilobytes, we drop the data, so it's removed from the event. And in the event truncation header, we set the event truncated Boolean to true. We provide the signed URL, and the signed URL gets put, this JSON object with the signed URL gets put onto EventBridge. And this is where the event attributes become important, because EventBridge by itself allows consumers to filter on any key in the JSON object, including the ones in the data object. But the data object might not be there anymore, so that's not a reliable source of filtering anymore. And that's why we provide the event attributes, because we promise that they will always be there, and that will allow the consumers to filter reliably on those event attributes, even if the data object is not there. And then they are responsible for fetching the original data object from S3. So with the large body offload in place, we have further improved flexibility, because now we can even support events larger than 256 kilobytes. Reliability is still the same, insight is still the same. So let's focus on that a bit. We now have very good reliability, we have very high flexibility, but we're still lacking on insights. So we have no idea which events are being published onto EventBridge, and we have no idea which events are being consumed by our consumers. And that is because EventBridge has no event-level metric collection. So it doesn't say this event type or this event version, we saw about 1 million of them in the last minute or whatever. That metric does not exist. In fact, EventBridge does not have a metric for the total amount of events published onto EventBridge. And that's kind of funny, because that is what you're being charged for. The only metrics that you have on EventBridge are the amount of events consumed by your consumers. But that might be a multiple of the events produced, because one event produced might be consumed 10 times. So to fill in this gap, we add a second responsibility to the ingestion function, because the ingestion function knows exactly which events are going through it. They know the producer, the event type, and they even know the event size. And we want to generate CloudWatch metrics on that data. So the basic approach would be to use the put metric data API, which generates metrics in CloudWatch. We saw that in one of the previous presentations as well. There's a problem there, because the put metric data API costs $1 per 1,000 invocations. But we're processing 14 billion events, so that translates to $140,000 per month just to generate this single metric. And that's not even possible, because the put metric data API is rate limited, so we can't even use it. Well, maybe that's to protect us against these giant costs. So luckily, there's another solution, and that is CloudWatch Logs Embedded Metric Format, or EMF. And what EMF does is you write structured logs in a certain format to CloudWatch Logs, and they convert it to metrics for free. And you do pay for the CloudWatch logs that you're writing, but those are not rate limited. And because we're only sending metrics, we're sending very small objects. And at 14 billion events, the estimated cost is about $2,000 per month, which is very acceptable. So let me repeat that. At 14 billion events, CloudWatch put metric data API would cost us $140,000, and EMF would cost us $2,000 per month. That's 98.6% in cost savings for exactly the same metrics. So let's look at how that works. Here on the left, you see the CloudWatch EMF. And you see at the top, you have the underscore AWS key, and you provide some certain structure that you must specify. So you must specify the timestamp and the CloudWatch metrics key. And then you specify the namespace and the dimensions, and those are all the keys that you want to see. You also specify the metrics and the type. So in this case, that's size, and we specify those are bytes. And then all the way at the bottom, you specify the values. So we say the producer ID is truck, event type is event B, and the size is 526 bytes. Now, when we write this log to CloudWatch Logs, it automatically generates the metrics you see on the right. So you see the namespace, the custom namespace, Event Broker e-commerce. You see that we have the dimensions, event type and producer ID. And at the bottom, you see the 3 metrics for 3 different events and their sizes. So that's all that we needed to do. And with these metrics in place, we can generate graphs like this, like you would with any other metric in CloudWatch metrics. So in this case, we see 3 events. We see their average size and the maximum size. And at about 2/3, you see a big drop-off in the size of one of those events. And it also allows us to measure exactly the volume, so the amount of events being produced per event and event type. So with EMF in place, we now know exactly what our producers are producing, which gives great insights. But we do not know yet what our consumers are consuming. So how can we improve on that? So before we dive into the metrics, we first need to explain a bit on how EventBridge and EventBridge rules work. So with EventBridge, you specify a rule or a multiple of rules onto the bus. And the rule consists of a filter, which specifies what you want to receive, and up to 5 targets. Now, best practice is to have only 1 target. And if you will need to do fan out, then you send that 1 target to SNS or to step functions or another EventBridge and do fan out from there. This collects a bit of metrics, but all that it collects is how many times this rule was invoked. So we can see how many events went through this rule, but we can't see exactly which events. Now, to solve this problem, we add an additional target to every rule that we deploy. And that additional target writes to CloudWatch Logs, again, just like EMF. But this time we're not using EMF because EMF generates metrics. And what we're trying to answer here is the question, which consumers have received this specific event? And that question cannot be answered in a metric. It can only be answered by a query. So what we do is we structure those logs to contain the consumer rule, so that's the rule that actually consumed it, and the application and event type. And we use an input transformer, which is a specific EventBridge technology to do that. So again, those logs are very small, and that allows us to keep the cost very low. And all of these events are written to the same CloudWatch log group. And now on this CloudWatch log group, we can use CloudWatch Logs Insights. And CloudWatch Logs Insights allows us to query the logs. So at the top, you see one specific event. It says the application is sort and the event type is event A-V0. And now I want to know which consumers are receiving this event and what volumes are they receiving. So I write a query that says I want to see exactly this event and tell me the consumer rules and their volumes. And just by executing this query, we get this result. We get a nice graph containing the volumes, but at the bottom you can see application is sort, event type is event A-V0, and we have 3 consumer rules, 3 different consumer rules, and these are the volumes that they received. And they might be different because they might have different filter rules. So with this in place, with the ingestion function, we know exactly what is being produced. And with these structured logs, we know exactly what is being consumed. So quick architecture recap. We have API Gateway that does request validation, and it uses the client certificates. We have large body offload in the ingestion function and S3 using signed URLs. We have producer metric collection in the ingestion function sent to CloudWatch Logs, and we have consumer metric collection in the EventBridge rules, which are also sent to CloudWatch Logs. And then from CloudWatch Logs, we use CloudWatch metrics and CloudWatch Logs Insights to actually read that data. Now, I promised you at the beginning that I would also tell you a bit about self-service and that I would be talking a bit about the CDK. So that's what the last few slides are about. The entire structure that you just saw, the entire architecture, is defined in a single CloudFormation template, or technically it's a few CloudFormation templates, but it's one single deployment. And because it's in CloudFormation, that allows us to do rollbacks. We can deploy a copy to a testing or an acceptance environment. We can do pull requests. We can do versioning. And the CloudFormation is really our single source of truth. And that's really nice to have. But the producer should be able to add components to this source of truth. They should be able to add routes and models. And consumers should be able to add consumer rules. So how do we let our producers and consumers manipulate this single source of truth? Well, the missing link here is the CDK. Because the CDK allows us to generate CloudFormation in many programming languages. And these are high-level programming languages. So they allow us to do conditions, they allow us to do loops, but they can also integrate with external systems, such as configuration files or an external API or an external database. And all of this connecting to these systems, is part of the CFN, the CloudFormation generation process. So we've built a separate product, which is the Event Broker Management API, and that is what our producers and consumers interact with. So they specify what they want to receive and what they want to send, the events that they want to send. We do validation and we do authorization in this API. And when it passes these steps, we store it in a database. Then we trigger a deployment, and the CDK deployment will fetch that configuration, use it to generate its CloudFormation templates, and then deploy that to the production environment. Now, this is how write operations work. So this is how they generate components. But of course, they also read from our environment. They read the metrics, they read the stats. And in that case, the API connects directly to the CloudWatch metrics and queries that we discussed earlier. So that's the current state of our solution. Of course, we're still building upon this and we want to achieve more. The things we're focusing on now are to reduce latency, because it takes a certain amount of time from an event to be published until it is received by the consumer. We introduce some latency with the Lambda function and API gateway, and EventBridge itself also introduces about half a second of latency. Now, I talked to the EventBridge team, and this is a high priority for them to bring this down. So we're really hoping to see that soon. But of course, we can also optimize our components. For example, we're looking at rewriting the ingestion function in Rust, which has almost no cold starts and is a lot faster to execute. We also want to reduce the amount of components, because what we saw today is only a part of the total architecture. And as AWS creates new features and services and releases them, we would rather have them deliver the service and us use them than us building custom components to do that for us. So for example, we're really hoping to see more advanced metrics in the future. And then we try to build more AWS native integrations with SNS and SQS and EventBridge instead of the HTTPS solution that we have now, and try to get rid of the client certificates in the longer term. So to conclude, EventBridge is a really powerful and flexible transport layer for your events. But it does not solve your entire set of business requirements out of the box. If you need additional functionality, you need to use additional services such as Lambda, API Gateway, and S3 to achieve that entire architecture that fulfills your business needs. And it's up to us as AWS engineers and solution architects to look at what's available in AWS, to choose the components that fit our business requirements best, and to combine them and integrate them into one single solution. And that's it for me. Thank you for your time, and enjoy your time with Jeff Barr at the end of this day.